Hello, hello. Welcome everybody to our another interview with another phenomenal protocol, another phenomenal technology from the Cyfrin team. My name is Patrick Collins. I am founder of the Cyfrin protocol, or excuse me, the Cyfrin team, Codehawks, and we do security and we just do everything we can to make Web3 a success. Here with me today, we have Christian and George from the Mind Network team, the Mind Network protocol. This is a protocol that I got introduced at SmartCon, which is the Chainlink Labs event that was put on, what was it, back in October? I think early October. I was introduced to these guys there. And this is one of the times where I'm introduced to a protocol, I'm introduced to a new thing, and I know almost nothing. And I love knowing almost nothing because this means I get to ask a ton of questions and I get to learn. And this fulfills the developer inside of me. So, Christian and George, welcome. How are you doing today?
I'm doing well. Thanks, Patrick. Thanks for having us. We're glad to be here.
All right, cool. And before we talked, George said he is here for technical and moral support. So, welcome, George. We're gonna pull you off stage now, and then any technical questions, we'll pull you back on. So, thank you so much for coming, George, and hopefully we talk to you soon. But Christian, yeah, if you want to do a quick introduction to who you are, what you've been doing, and what's going on.
Yeah, so I'm head of BD and marketing at Mind Network. I'm on the founding team here, and Mind Network is a zero trust layer. We're going to talk about that a little bit today. But I've been in crypto for a couple of years, and mostly my background before that, in my life before Web3, was leading BD and sales teams in medical technology. And so I took the MIT blockchain course a few years ago. It was very rewarding. Christian Catalini was an admin, and we had to come up with some sort of solution that would use real world blockchains in the real world. And that kind of started my journey. And so I've landed here with the Mind Network team and just really interested in data privacy and data security and in solving some of the problems that we have in Web3 that is siloing data and fragmenting value and being serving as a barrier for TradFi to really come into Web3 and for us to get mass adoption. So that's part of what we're working on in Mind Network.
All right, cool. So you put out a bunch of different terminology there, right? You said zero trust layers, siloing data, fragmenting value. There's all this stuff. What is the elevator pitch? What is Mind Network at the highest level, at the most general point? What is Mind Network?
So super high level, so we embrace a zero trust framework for data. So zero trust means never trust, always verify data. So that means the data at rest, at compute, and at transmission must be verified and encrypted. So we're not trusting anything. So this is kind of a newer framework. This is not the framework that Web 2 uses. And in Web 3, it has a double use case because it actually adds privacy to Web 3. And Web 3 has a privacy problem. All data in Web 3 is public. So everybody can see your wallet, see your transactions, geolocational data, the art you own, the DAOs you participate in. And as more use cases keep arising within Web 3, all this data just keeps being public. So the zero trust framework that we built is comprised of two technologies. So we use zero knowledge proofs for the input-output gateway. And then we use fully homomorphic encryption. And we're adding a few other technology, or at least another technology to that as well, to kind of expand our offering. But fully homomorphic encryption is really the key. So you're going to be hearing a lot more about FHE. You probably already are. A year ago, almost no one, I mean, there were only a few really companies in Web3 that were using FHE, but it's been long considered the holy grail of cryptography. And the reason for that is because you encrypt data with FHE, you encrypt data, and then you can run third-party computation upon that data without the need for decryption. So if you just think about that, at face value, think of all the types of data in the world that are siloed on private servers, that are siloed because of strict regulatory policies, because it's sensitive data that we really can't access the insights from, and that we certainly can't deliver to the user in a variable format where the user can do whatever they want, or run their own AI on it, or learn more about themselves. So thinking about health, think about banking, think about all of it. So this has got a really broad use case, and it's still relatively early stages. It's probably now kind of where ZK was in 2020, but we have a number of use cases already that it works really well for. So it's a very exciting technology.
All right, great. Thank you for the high level overview. So a zero trust framework for data. You talked about data being verified, encrypted, adding privacy, using this ZK proofs and this FHE, fully homomorphic encryption. Hopefully I'm saying it right. which you said is the holy grail of cryptography, which sounds really interesting. I like things that are the holy grail of something. So with all these technologies, though, you said there's a number of different use cases. To me, that's the most important thing. A technology is only as good as the problem it aims to solve. So what are the problems that this is aiming to solve? And then you mentioned, hey, we have some use cases already. What are those use cases that this is already solving?
Well, so our first product was a data lake, a zero trust data lake. So if you think of basically being able to put any kind of data, semi-structured data, unstructured data, structured data into a data lake, making it a little bit broader than a database, and then being able to run compute on that data, you can start to take data off chain and put it in there, on-chain data, and you can run something like a comprehensive risk profile, say for underwriting loans in Web3. So this is a use case that we explored. We work with decentralized storage providers. So giving DApps that work with them the ability to do the same, to have a place that they can have cold data storage and store this data over time and have it all be encrypted. And again, in Web3, this is now offering privacy with data that's very useful. And we've been kind of expanding. So now I think a really exciting use case is we're looking at bridging. So if you think about an FHE bridge where transactions, token type, volume, sender receiver data, all that stuff can now be encrypted as well, made more secure with FHE and also made more private with FHE. So this has a pretty big use case. If you think about TradFi coming into Web3, they have got compliance that they've got to work with, which means like, banks can't front run their own trades. So how do we find a way to keep it a little more private trades? This also is relevant for retail users. And if you think about within Web3, the same thing, bridging is one of the kind of more torturous parts of the Web3 infrastructure. There's been a lot of bad behavior with bridges. So by adding FHE, you kind of add this extra layer of security, because FHE again is encrypting the data and it's quantum resistant, so we don't have to worry about quantum computing as that technology develops over the next several years.
Okay, so we mentioned a couple different use cases here, right? We talked about bridging, we talked about the zero trust lake, which sounds like that's the first product. Can we hone in on the zero trust lake for a second? Because I don't think I fully understand that. So you said you launched this zero trust lake, and I'm just looking down at my notes here. And one of the use cases is this comprehensive risk profile for something like for insurance, working with apps so they can store this data that's encrypted. What is this, just so that companies can have private data? In my mind, hey, like, why don't I just put my data on my hardware device that I bought? What is this giving me, right? Let's say I am writing loans, and a company comes to me and they go, hey, here's all of our here's all the risk profile calculations that we do. We store it on our hardware device. We store it on this black box that we have in our server room. Why do I need this zero trust data lake? What is this giving me? What is this giving this protocol? And then I'm asking this from a Web 2 perspective, even though I know you're talking about dApps and stuff. Maybe the answer is, hey, Web 2, this doesn't make sense for Web 2 peeps.
Yeah, so well, in Web 2 specifically, you're talking about if there's a server, that is the billion-dollar question. So it's like, how do you get a big brand or big Web 2 company to release the insights, themselves? What we're seeing some interest around is big brands that are coming into Web 3, like Nike or Adidas. They're worried about basically publishing their customer list. They're worried about vampire attacks. So if we can add a layer of privacy to whatever these companies decide to tokenize, now they're at least not publishing their customer list. So that's a pretty exciting use case. If you're thinking about Web3, so here's a better example. Think of DeepIn. So DeepIn's got this great narrative within Web3, monetize your data, monetize your devices, right?
And then for users who are not familiar with DeepIn, just explain DeepIn real quick. Yeah, go ahead.
So decentralized physical infrastructure networks means, taking your wearable, taking your Fitbit, taking your the car dongle, taking your weather device. I mean, all these devices that we have, your door cam, and basically sharing that data to the network and providing feedback to the network that these devices in a Web 2 framework are doing anyways. But instead of enriching somebody else's business model or their AI or whatever, you're actually getting paid for sharing that data. So it's a great narrative. It's a really kind of foundational, kind of core Web 3 principle behind DeepIn. But right now, if you've got a device, if you've got a door cam or some sort of weather or your wearable device, when you share that data, you're actually sharing geolocational data. you're sharing the device IMEI or serial number, you're sharing other kind of data that you might not want to share in order to receive the rewards, receive the tokens back, right? So we add just a privacy layer in there so that you're not always constantly, giving up this private data. So that's kind of the Web 2, Web 2 and Web 3 use, kind of the why would they want to engage with our zero trust data lake?
Definitely. Yeah, that makes a lot of sense. The classic example that I like to give, and I feel like a lot of people usually give when they're talking about ZK is, hey, say you want to get into a bar, but you don't want the bartender to know how old you are, but you do want the bartender to know you are old enough to get in, right? Right now, you just give them the license. The bartender knows everything about you. They know where you live. They know your exact age. They know if you have contact lenses or not, right? They learn all this extra information about you, and you just want to give them, yes, I am old enough to drink. So what you're saying here is the zero trust data lake. It sounds like what you're saying to me, unless this was just an analogy here. The zero trust data lake can do that for multiple types of data. Like, let's say you wanted to sign up for rewards for using your, I use like the doorbell camera, right? Let's say you want to, hey, every hour that it's on, you get like a token or something weird like that. And you want to push up that it's constantly on, but you don't want to push up where it is, who is at the door, what it's filming and stuff. So you're saying the zero trust data lake right now can actually do that.
Correct. Yep. Exactly.
That's pretty sick. That's pretty cool. Okay, so that's kind of the more Web 2 side. So on the Web 3 side, to me, this is where this gets even more interesting, right? Because we actually, in the Web 3 world, we have a lot of decentralized storage solutions right now. I've done a ton of content. Anybody who's watched some of my content, they've probably seen me do content on Arweave, on Filecoin, on CN Network. We have all these decentralized storage solutions. However, the encrypted nature of them is different solution to solution. For example, like Arweave, all the data is going to be public. For something like SIA, all the data is going to be encrypted. It's decentralized, which is great because it does get that resistant property. Censorship resistant property. It does give that if a server goes down, the data persists, but it doesn't have what we're talking about here, which is the zero knowledge aspect. So in the Web3 world, you said, again, going back to the use cases here, what are some of the Web3 dApps that are using this zero trust data lake right now, if there are any?
Yeah, we've got a few. So we're still, we have not launched a token yet. We do have our SDK live, but the use cases that I said, there's a legal use case with legal documents. Actually, a broader way to think about this is that from a really basic perspective, there's transacting tokens, sure, but what about messaging? What about famously a few months ago, MetaMask got hacked, and it wasn't any part of the protocol or the core tech. It was just because it was their support tickets. Because support tickets were an email format, and there was information in the support tickets around wallets. So now a hacker could see email associated with wallet, maybe with a Twitter, maybe with so it's like it's a lot of this kind of Web 2, these Web 2 tools that we're still using in Web 3 that actually is a much broader use case as well. So if you kind of take that and envision, messaging and connecting Web 2 pieces of your business to Web 3, that's also something really helpful and very simple to add this technology to.
Yeah, so help me understand kind of where this would make sense to apply. So right now, it sounds like right out the gate, we can apply this to a ton of Web 2 places. And I can imagine how I would want to approach it to Web 3. But right now, is the aim for my network, is it more Web 2 or is it going to be Web 3 later? Because right now it feels like this is immediately applicable to Web 2. And this is probably applicable to someplace in Web 3, but I'm having a harder time visualizing it.
Yeah, so no, we're definitely Web3 native, and Web3 is our primary focus in terms of BD. The Web2 portion has come because our partners in Chainlink and others are trying to bridge the gap. They're trying to bring TradFi in and Web2 brands in. They're really making an effort, and it's getting a lot of fuel because the Bitcoin ETF looks like it's going to be approved soon. So that means that a lot of Bitcoin can start to, come from TradFi. TradFi can enter Web3 at least through Bitcoin. So the question is, is the process to go from Bitcoin to other chains easy? Is that something that we can manage? Obviously, Chainlink is working on this because that would mean a lot of liquidity, and that would mean also We talked earlier about fragmented values. So at SmartCon, there were a ton of speakers from banks, keynotes from banks, head of digital assets and head of product innovation at these big banks. And they're all saying like, look, the problem with Web3 is like, if we come in through Bitcoin or Ethereum, it's kind of a heck of a lot of work to then bridge if we want exposure to other assets. Like what if we want to have Avalanche? So that's a problem that needs to get solved. And it's also a problem that we have right now because if you're bootstrapping, if you're a DApp in Web3, you're going to pick one of the top 10 chains to go with, and then you're going to basically work through their, the DApp, the other DApps in their ecosystem first for like BD, and you'll try to get friends and you'll try to do partnerships, and you're locked in the chain until you integrate. And sure, EVM makes it a little bit easier, but you're still, the liquidity could be better, and you could have better BD access as a DApp starting up if you've got this kind of cross-chain interoperability. So the real Web3 use case is bridging chain to chain, mostly public chain to public chain. And so that's going to be kind of our niche, is this bridge piece. It just so happens that a lot of the core tech for this bridging chain to chain also is really helpful for Web 2. I think that, if we are still subscribing to having metrics and to the fact that we might be coming into a bull market maybe in the next year or so, Web 2 seems to have been in this bear market really preparing. We know that Nike and Shopify and Gucci and all these brands that launched NFTs, they winded down those programs, but they're still doing a lot of research and they're still figuring out how to play in this space. So you might see a lot more enthusiasm and excitement over the next year. So we want to be ready for that, and we want to build infrastructure in Web 3 that allows everyone to go chain to chain and from Web 2 and Web 3.
Right. So here's what I'm having a hard time understanding. Right. So we're talking about the first product being this zero trust data lake, right? Makes a lot of sense. We're storing data using zero knowledge proofs, using fully homomorphic encryption, which we'll probably get to in a little bit, but I get that, right? We're storing data in a way where we're not revealing additional information outside of just what is necessary. Great, makes sense to me. Use cases Web 2, use cases Web 3. Now I feel like we've taken a leap now. Now we're talking about bridges is going to be kind of the main focus in my network. Can you talk to me about that jump? Like, how do the two relate? There's a gap here for me. How do we go from the data lake to now we're talking about bridges?
Yeah, good call. So you can think basically of us as a layer that can be inserted into different parts of the tech stack. So if you think about like above layer one, let's talk about the assets. So FHE and ZK can be basically made to protect the asset, the token type, and the volume, right? So that's kind of like an FHE EVM, right? Think of that as like, so you just maybe, Phoenix is this first FHE EVM that just raised.
Is that a thing that exists right now, an FHE EVM? So
it just, Phoenix,
it's Phoenix called is Phoenix. The name of. Very cool.
Yep.
Okay.
And they spelled it FHENIX. Very clever.
Okay.
But
cool.
Yeah, there's a lot of excitement about it. And so it's going to be, this like, privacy preserving native blockchain. So that's very cool. And above that, so that's one thing that we can offer. So, with some partners, we can kind of do what they're doing, but we're also complementary to them because they're a layer one chain. There's no bridge involved. So if you start talking about bridging, and I did skip some steps to your credit, so I'll go into them a little bit now. Above that, you actually have a way to use FHE to hide the sender receiver data. So we use a stealth address protocol, which that research started coming out, I think 5 or 6 years ago, if I'm correct. George might jump in and yell at me right here, but I think about 5-6 years ago, you started to see that. So stealth address protocols have been around. We added FHE to it so that basically there's a middle address where the funds are sent. It's a stealth address, and the only person that has access to that is the receiver. So in this way, we add FHE at another layer of this overall process. And then the data lake is kind of, a place to kind of store the data. So, and then on the very top, we just have the SDK, which is plug and play. So this kind of core framework, and then, this core framework can basically essentially be inserted at different parts of the tech stack. So yeah, our first was a data lake. That's kind of our core product because you kind of need that to do the rest, more or less. But then we just found other applications of it.
Got it. Okay, so Mind Lake. So I have your documentation up right now. So I'm assuming this data lake, this is called the Mind Lake. Is that correct?
Mm-hmm.
All right, correct.
Yeah.
So that's the core network. And how long has that been around for?
Since about March, April. We had our test net over in June. And it was about a 2-week test net, and we had 13,000 applications. That's been live since then. And then the SDK, I think the SDK was probably launched around similar time.
Oh, so this is like this year.
Correct. Yeah. The company was founded a little less than a year ago. Yeah.
Well, Very cool. Congratulations there. So I almost feel like there's more rabbit holes to go down based off of that description right there. So thank you for going back to some of the bridging. And we were talking about a lot of really interesting things that I think make sense. So we started with this mind lake, this data lake, right? Which is this, hey, it's a way to store data. I'm assuming it's also storing it in a decentralized context. I guess that doesn't really matter if it's zero knowledge. Does it matter?
We're not natively decentralized, but that's why we partner with Arweave and IPFS and BNB Greenfield. Yeah. And it's also a data lake for hot data, right? As opposed to cold data.
Got it. Okay, makes sense. So we can talk about that a little bit more. So the Mind Lake itself is a network. Is it a blockchain, or is it like
it's a peer-to-peer, like a peer-to-peer modular network? Yeah.
So kind of more like an IPFS.
Mm-hmm.
So like an IPFS where we have a peer-to-peer network where data is ZK. So and this is kind of interesting because you said, hey, it's not necessarily decentralized. However, is it accurate if I were to say the zero knowledge storage of it almost makes it so that it not being decentralized doesn't matter, because the centralized actors won't be able to see that unnecessarily known data, if that makes sense? Like, for example, going back to the bar example, if I store my driver's license, or if I store whether or not I'm old enough to go to drink at a bar on the Mind network, users or nodes or whatever the runners of the protocol, will they be able to see my sensitive information?
Yeah, exactly. Yeah, you're exactly right. It's kind of like first things first. Let's solve the first problem, and which we can do with ZK and FHE, and then to decentralize over time is a matter of just letting, once we tokenize, we would do something like a proof of computation mechanism, that'll actually allow for the network to decentralize.
Yeah. So right now though, can the runners of the network, can they see that sensitive information or not yet? Or excuse me, or they cannot? They can't.
No.
Very exciting. All right, cool. Makes a lot of sense to me. All right, cool. So now that I think I fully understand kind of the data lake, at least from a high level, it's a network storing data in a zero knowledge sense. Awesome. Then we kind of jump to, all right, cool, bridging. This is this new thing. That's when we talked about Phoenix, FHE, EVM, very clever, which is zero knowledge EVM. You talked about stealth addresses, which is something that I think a ton of people in the ETH ecosystem don't even realize how big of a deal that is. It's kind of crazy that we're all like, hey, by the way, here's my bank account balance. Whenever people have like an ENS name, they're like, hey, here's my ENS address. By the way, this is exactly how much money I have. To me, that is the craziest thing. And when people like flaunt their ENS names in their profiles, I'm like, hey, that's cool, but like, why? Why are you doing this? So we're talking about stealth addresses. We're talking about
the fact that you can just Google search somebody's wallet. You can Google search MetaMask wallets now, and it just brings you right to it, right?
Which is pretty terrifying. So is this Phoenix network? Is this the next product that the Mind network is working on?
Well, so Phoenix is its own. They're their own company and chain, right? So they're actually their own. They have their own raise. So we have complementary technology. Yeah, Phoenix had a raise just a few weeks ago. They had their A, and they are going to be the official FHE EVM, privacy preserving native chain.
Very cool. So Mind network, if I can do another analogy for Web3 people, Mind network, are you kind of the Ethereum foundation, and Phoenix is like Geth, if you're familiar with that analogy, like the client? I don't know how much of a stretch this is.
Yeah, kind of. I think so. They're the FHE chain. We're the FHE bridge. That's going to be what we'll be known for, I think, is our flagship product, which the Zero Trust Data Lake is a part of.
Got it. Okay, cool. I think it makes sense. So it sounds like, Phoenix is they're their own thing in this FHE world. You are talking about this bridge. I'm on your documentation page. Actually, let me even share it real quick, because I think this is really nice for people who are watching this. It's on the overview page. Excuse me. Let me zoom in a little bit. Right now, we talked about the Mind Lake, right, which is this core network, which is this ZK storage here. Where is the bridge, I guess, is my next question. Which one of these is the bridge? Is the bridge built out of one of these? Where's the bridge?
Oh, so currently it wouldn't be in this one. I might have to get you. We actually do have it. We've got a Gitbook for it that I could send you. It's not here.
or we're releasing some alpha
You
here.
know
The
what? We may
bridge
have not.
docs aren't up yet.
Yeah, we might not have the bridge doc up yet.
Okay, no worries, no worries, no worries. All right, cool. So some alpha bridge docs to come. Very exciting. So cool. So bridge docs are coming soon, but how does that fit into this overall picture that we're talking about here? So I'm still missing something. So zero knowledge bridging, would this be from any EVM chain to any EVM chain? Would this be purely FHE chains? Why do I need this zero knowledge solution for doing bridging? Is this just to almost like the tornado cache of that's probably a sensitive topic, the tornado cache of like cross chain USA, don't watch this video. Yeah, how would you describe it? Like, what does this look like?
Well, so yeah, you don't have to be an FHE chain, obviously, to send or receive. You don't even have to be incompatible. That's just a little bit more work. But just think about it as you've got assets on Avalanche and you want to send them to Ethereum. And you don't want that transaction to be public. So you don't want the sender wallet to be public, the receiver wallet to be public, and you don't want the volume to be public, or maybe the act itself, right? You don't want people to know that what you're bridging to. So that's really that's the key solution that we're providing for. And of course, we have to have built into this a way to be compliant. So we are working with Chainalysis so that we're not we don't want to be able to make it so that bad actors can just get away with straight robbery. But the point is right now there's basically no privacy layer in Web3, and we need to make it a little bit harder for just to be able to search a wallet and see somebody's entire net worth in their ENS.
Yeah, 100%. So one of the first things we talk about, so obviously with Cyfrin, we're a security firm. One of the first things we talk about is the first step for an attacker is to identify a victim, identify who they're going to attack. And the way they do that is by collecting as much information as possible. So privacy is normal, privacy is good. And it's actually crazy how long we've gone in the Web3 ETH DeFi ecosystem, kind of skirting it. We've said like pseudo anonymity has been good enough, but it's really not. It's definitely really not. So this is really interesting. So can I ask, what exactly would this look like? So, and then I would like to ask this question with Chainlink's CCIP in mind as well, right? It's a tool that I'm obviously very familiar with. That's where we met at the SmartCon Chainlink Labs event. So what would this look like? I'm aware of how CCIP works with their network of Oracle nodes. And for those of you who are watching, just a quick refresher on Chainlink CCIP. The way that it works is basically you send a transaction on chain 1 that emits an event, essentially. A group of Chainlink nodes read that event on chain 1. They lock your funds or they lock your message on chain 1. And it goes through a couple of different processes where there's a couple of different networks of nodes that actually verify that there's no fraud, etc. And this group of oracles, as a group, as a network, as a decentralized cluster of nodes, they call a unlock or a send message function on chain 2, right? So you can really think of it as just a group of decentralized nodes reading your message on chain 1 and them sending it to chain 2. So that is how CCIP works. Essentially, how would my network bridge, zero knowledge bridge, fit into this?
So CCIP is essentially going to be like a messaging service, right? So that's kind of the messaging that we're coming in and adding FHE to. So right now, currently, any data that's going to go in the Dawn is in the Dawn, right? So that data.
For those who don't know, a Dawn is a decentralized Oracle network. It's like a group of Chainlink nodes, essentially.
Right. So yeah. So if you've got KYC data that is necessary to execute the transaction, well, that's going to go in the decentralized Oracle network. The token type is going to go in there, the volume. And so obviously CCIP is focused on banks, and banks don't want that information all to be public. So they've got the technicals figured out, right? The burn and mint process that you just described. But what they're trying to figure out is like, how do we get the security to be compliant with what our customers need, and how do we actually mask some of this, without completely masking it, to make it so that really, that's kind of like what they were doing with Swift. They just proved functionality of actually being able to send assets and value from the real world into Web3 and back again, and public chains to private chains, and all enabled with this messaging network. But the next step of that is how do we can we encrypt it and still maintain the validity of the information and still allow for everything to go where it says it's going to go in a secure way. So think of it, short answer is, think of it kind of like a layer on top of CCIP.
Yeah, I'm really liking what I'm hearing, because this sounds like it's going to be really important in the coming years. And then maybe this is probably too difficult a question because it's not live, or the docs aren't live yet, right? So we would probably want to see the docs. But what would this feel like, right? I know exactly what it feels like. I know what it looks like when I send a transaction through CCIP, right? Pop up on my MetaMask, I hit the confirm button or whatever wallet that I'm using, transaction on the ETH or whatever chain I'm working on, the nodes read it, and they send a transaction on the second chain. In this setup, do I hit that MetaMask button, the Chainlink nodes route the data to the mine network? No, that wouldn't make sense because the data would be public. Do you send the transaction through mine network? Mine network sends it to the EVM network, which then sends it to the Chainlink network, which then sends it back to mine network, which then sends it to chain 2. What does this process look like? What are the steps, if you will?
Yeah, this is a great. I had a chart I wanted to show you, but I was told we probably shouldn't do that quite yet. So we are a little early, but I think let's bring in George, and George can maybe give us a safe explanation without touching anything too sensitive.
Fair enough.
So George, let me know if you want to hop in.
Welcome back to the stage, George.
Yeah, sure. Thank you very much. Yeah, so in this case, CCIP, including DOM, don't need to change anything right now, because what we have done is we will just send a normal transaction, but to encrypt the data and also the amount of the token through CCIP. So CCIP will treat this as kind of normal transactions. So we'll enjoy the current, the concurrency, the consensus security through CCIP. So in that case, to answer your question, don't need to treat this as any kind of special security. So how the security can be guaranteed? That is because we deploy the sender and also receiver contract on both chain, and then connecting this to the router contract published by CCIP. So all the encryption, decryption are handled by the sender and the receiver smart contract. So that is happened fully online, on chain, with the smart contract to work together.
So let me pull up my drawing pad real quick. 1 second here. So I didn't quite fully understand that. So here's what it looks like right now, right? We have chain 1 sends a call, Chainlink CCIP executes and unlocks it on chain 2. So we have my network, which is going to be where in this? Where am I putting my network here?
Okay, so firstly, on the chain 1, we will deploy a sender contract, and the sender contract will connecting to the router in CCIP.
Okay, so we're going to do the router CCIP. So sender contract connects with this. Yeah. So, okay. Yeah.
And then we also have a receiver contract, which is on chain 2.
Okay. Great.
Yes. So, for example, over here we have two users called Alice and Bob. Alice is staying on chain 1, and then Bob stays on chain 2. So Alice wants to send from chain 1 to chain 2.
We have Alice. And we have Bob over here.
Yeah.
Okay.
Yeah. So on chain 2, we have another smart contract to handle the stealth address protocol. So let's say SAP contract. Yeah.
Okay.
So Bob, firstly, he will register, will do a registration on SAP to publish his public available information. For example, some of the PK, those information. Yeah.
So he's gonna register what?
Register his PK, which is a kind of encryption screen we develop in the SAP.
So he's gonna register his PK, which is an encryption what?
Encryption of the stealth address.
Sorry, one more time.
Encryption of the stealth address.
Yes.
Okay, so Bob's going to register their stealth address. Okay. And this transaction of Bob registering the stealth address, does this go through the mine network, or is this, are they doing the computation for the registration off chain? How does that actually work? I'm assuming chain 2, chain 1 and chain 2 are kind of regular or regular is a bad term, are just EVM chains.
Chain 1, chain 2 could be any chain. So it depends on how the CCIP, the go-to-market strategy, and also the speed. So right now supporting for EVM chain and also a couple of non-EVM chain also. CCIP is already support that. So we will follow CCIP's step and also coverage. Yeah.
Okay, so Bob is going to register their stealth address, right? Is that
so?
Yeah.
Bob will register the PK. And this PK will be used to calculate the stealth address. So by the time of the registration, nobody knows, even Bob don't know what the stealth address is going to be. But this is just one of a part of the information will be used in the future to calculate the stealth address.
Okay. And then so people who are watching this, let me know if this diagram is helping or making it more confusing. I'm hoping this is helping because I feel like I'm learning more and more as we draw on this diagram. So, okay, cool. So Bob registers his PKE. He's going to get this address at some point. He doesn't even know what it is. Is this just a function on this SAP contract called like register PKE?
Yes, that's correct.
Okay, yeah. Wow. Okay, so he'll register the PKE. Then what happens?
So then Alice decided to send in to Bob. So he will check SAP contract on chain 2, and then to retrieve that PK by calling and then passing Bob's EOA address, for example.
So Alice is going to check the SAP for Bob's PKE. Is that what you said?
Yeah.
PKE. Now, how does Alice...
No, Bob's check based on Bob's EOA address, because Alice want to send into Bob, right?
Based on Bob's EOA, but in this sense, so Alice knows Bob's EOA, right? So Alice will know how much money Bob has, right? So if Alice needs to know what Bob's EOA is, doesn't that kind of break the whole ZK aspect?
No. So Alice will get Bob's. So in this case, Alice knows he's going to send it to Bob, and also Bob will know that the money is actually coming from Alice. So both parties knows each other. But anyone else don't know there's a connection between Alice and Bob. So that's the result we want to achieve.
But does Alice? So I'm assuming Bob would just have to make a burner EOA if Bob doesn't want Alice to know, how much money he has, for example, right?
In this case, it's not a don't need to. Okay, maybe let me explain further. So Alice is to get Bob's PK. So the -9 you draw, Alice basically just to get the PK.
Okay, great. So let's Alice gets Bob's PKE. which is great because
Yes.
that's encrypted. It doesn't have
Yes.
any information like she can't get Bob's EOA from
Yes.
the PKE. Okay,
Yeah.
awesome. That
And
makes
this
sense.
registration will help Alice to prove in the future that he's sending to this, stealth address, which is based on the calculation on top of Bob's PK. So
Got it.
this is for proof purposes. Okay.
Okay.
So once Alice gets the PKE, then through a calculation through the SDK, he will be able to calculate a stealth address for Alice to send.
So then Alice is not using the Mind network per se, but the Mind SDK to calculate stealth address. And
which is a random wallet address you can consider equivalent.
Okay. So I think I'm starting to understand this even more. So with this PKE, I'm going to make this a little bit bigger here. With this PKE, not only could she use this to calculate the stealth address, but could she also use this to encrypt message that she wants to send Bob?
Yes, particularly metadata, for example. In Swift use case, they normally need to send a larger body of metadata. Putting all those metadata into on-chain will be expensive. So that data can be encrypted also. Yeah.
Got it. Okay, cool. So then I guess my question is, that actually made it worse. I was trying to make that look nicer. So this makes a whole lot of sense to me. And I feel like with this setup though, I guess again, here's where I'm confused. Where's the Mind network? Because it feels like, from my understanding of cryptography, right, we could do all this off chain. We could do this, get encrypted data, and we could send this encrypted data across CCIP. People could read the data, but it doesn't matter because it's encrypted. Does the Mind network step in? Does the data go through the Mind network? Where does Mind network happen here?
So in this case, Mind network or Mind lake is optional. Okay. So stealth address can work without Mind network. They can just transfer the token without any message, for example. But for example, if you're going to transfer NFT or even in the Swift use case, they want to transfer the actual bank instructor. So those data are large amount of data. And also they require a cross-chain computation. So that means they need to run a query and calculate on top of for those data. So then the Mind lake become a place for them to use. Yeah.
Got it. Okay, I think I get it. So let's say you wanted to send this message, which requires, again, going back to the bar analogy, right? Hey, I want to send from chain 1 to chain 2. Hi, I'm Alice. I'm old enough to drink. And I have that data stored in Mind Lake. So I would get that ZK data in Mind Lake that I'm old enough to drink without revealing the information of how old I am, where I live, etc. We'll use the Mind SDK to encrypt the data from the Mind Lake. We'll put that into a EVM contract with EVM sender contract, which will then trigger CCIP to send this encrypted data over to chain 2 on Bob's stealth address. And then Bob can let Alice into the bar cross-chain. Is that correct?
That's correct. Yeah.
Sweet. That is very cool. Very cool. So it almost sounds like, the Mind network aspect here. So the Mind lake data, the data lake here, this is really cool for storing this data, for getting this data, for working cross-chain with. This is one of the big things that I've talked about a lot, about how data is going to be one of the key pieces to making blockchain, making Web3 even better than it already is. And I guess I can stop sharing because I think we got it. Making Web3, making data make more sense here. But we haven't figured out a good solution of combining data with our smart contracts. And it sounds like this might be one of the key pieces that gets us there, because data has always kind of been this sensitive, don't touch it with a 10-foot pole because it's hard to use. So I guess my other question is, so with the bridging, this almost sounds more like a standard to add on top of Chainlink, to add to CCIP, to add to these smart contracts, as opposed to the Mind network actually stepping in and facilitating some of this. It's more like, hey, we can store this data in a ZK way, and now we can send it and post it to chain and do all the amazing things our smart contracts can do. Is that accurate? Do I have the picture here?
Yeah, that's correct. So our bridge is building on top of CCIP, and it doesn't require any changes for CCIP right now. So we are just an extension or plugin you can consider for CCIP. And we also design our product to be to be modularized. So you can, if you want to transfer token without message, then still suggest protocol is good enough. And if you want to sending encrypted data as metadata, then you can using Mind Lake together on top of it. So it is modularized and giving the space for developer to choose. Rather than tightly coupled together, so to limit their creativity and also the imagination. But in the background, that what we want to achieve is no matter for token and the data, they are fully controlled by user. User are fully having the full ownership for those data, and Mind Lake can be the place for them to implement that. As you can see, the example you just draw, users EOA have the full control to upload, to retrieve, to query, and then also to do the calculation for their data in this case. Yeah.
This seems really sick. This seems really cool. This is very exciting. Great. Well, thank you, George. Maybe my next question is for you too, actually. Actually, before I ask my next question, are there any other thoughts, comments on that diagram? I really thought that illustration was phenomenal, right? Hey, it sounds kind of silly. Like the example is, oh, I'm Alice. I'm over 21. Can you let me into the bar? But all of my information, there's a $5 cover, but I have $5 on ETH. I don't have $5 on Arbitrum or whatever other L1. Can you let me into the bar? My data is stored in a ZK on the Mind Lake. Sounds like a silly example, but to me, it really illustrates the power here. Is there anything else that we want to add before we move on to my next question here?
No, I think so. Just to be high level again, because I'm the high level guy. It's really putting the privacy protocols that have existed, but they have been delivered to us from centralized entities in the hands of the users, right?
Yeah.
So that we have those kind of same protocols.
Definitely. Very cool. All right. Awesome. So next question. Fully homomorphic encryption. What is that? How does it work? Thoughts?
Christine, do you want me to pick up that question?
I'll kick it off, and then George can get into. George can start talking about lattice. How about that, George? You coming for the lattice part? So fully homomorphic encryption is basically a type of encryption that allows for data to be encrypted upon or encrypted, and then third-party computation can run on top of that encrypted data without actually having to decrypt it. So the data stays in cipher, right? It stays in ciphertext. It doesn't actually have to be put into plain text in order for you to run computation on it. And so there's actually different kinds. It started out with homomorphic encryption. And this goes back actually to, back to like the late 70s, early 80s, and the name might have changed, but that was kind of when the research, I think, started. And George can cut me off. And then homomorphic encryption was basically just the ability to run basic, simple computation on encrypted data on the ciphertext itself. And then we moved into fully homomorphic encryption, was basically adding computation types. So addition, subtraction, multiplication, you can do more now. And then our kind of homebrew is this adaptive fully homomorphic encryption, which George can go into, but actually is meant to make the computation process more efficient.
Yes. So if you consider, without a HEPG, fully homomorphic encryption, if you want to share data with others, and then basically once you share data, raw data to others, then people will get a copy of your data. And if you don't share the data but want other people to query on top of it, then because other people, they don't have your data, they have to trust your computation, right? So those are the dynamic always happens in the industries. So homomorphic encryption, what they can do is they can encrypt data by themselves on their own side, and then they can share this encrypted data to a third party or whatever. And then third party will be able to run the query to do the computation, follow the instruction to get results by themselves. But it is encrypted. The results is also encrypted. So the people who want to get results, they are handling the processing part rather than trust a third party to do the computation. But in order to get the results, to decrypt the results, then he needed to get permission from the owner of the data. So in this case, our data can be encrypted, can be shared with anyone, but I will have the full control. That's going to be the huge differences comparing to how we are using the data and how we solving the data ownership in the future. And how exactly this HFHE works? Maybe I can talk a bit more about the history or the background. So the HFHE start from.
So before we dive into the background, I feel like we opened a couple of different cans of worms that we only have 8 minutes to go down. So we'll see how many of those we want to go down. But one of the things actually that I think is really interesting, and that's to me is basically mind blowing, and I'm still trying to wrap my head around it, is to me it sounds like at the high level, fully homomorphic encryption is, I have written down here in my notes that I'm taking, type of encryption that allows data to be encrypted while still being able to execute computation on that encrypted data without the data being decrypted.
Yeah.
Is that terrifying? Because at first thought, that is terrifying to me. For example, if I encrypt my data and I go, okay, cool, my data is safe, nobody can mess with it or know stuff about me, and then I run a brute force algorithm that says, oh, okay, cool, well, I can check if you're old enough to go to the bar this year, if you're old enough to go to the bar next year, if you're old enough to go to the bar in 3 years, or last year, or 2 years ago, and you can keep running this computation. Can't eventually you learn this information? So yeah, my question here is that terrifying?
No, it's actually.
Okay. Sorry, is it terrifying? No, not terrifying. All right, cool.
Yeah.
It's a good question. But yeah, George will talk about the Turing completeness of it, right, George?
Yes, because in this case, firstly, HFHE right now is mathematically being approved. So this process can happen without to disclose any kind of sensitive information. Secondly, is industry is already implemented, and you can see we already develop this in our use case. Particularly when you try our product, you will see this actually works. This is not a dream. Thirdly, it is natively support the encryption scheme like Lattice, which is which can support for post-quantum attack. So this is a post-quantum cryptography enabled from day one for HFHE going to work. So even HFHE, this work start from 2009, which is very recently by Gentry for his PhD work in Stanford. But after that, after the first paper, the industry has been attracting a lot of top researchers and also companies. For example, Intel, Microsoft, IBM, and Google. They are all spending a lot of resource on that, and then they recognize this as a kind of holy grail solution in the cryptography. It will solving the last mile challenges for the privacy computing, because now the data can be freely given to anyone, and they will be able to get their results by doing the computation by themselves. But the data owners still have the confidence to protect the data. So this is the last miles can be solved by this HEP-HE. But I want to mention that before HEP-HE, there's another term called HEP-HE, which is just called homomorphic encryption.
Wait, so before FHE, you said there was HE. Is that what you just said?
Yes.
Okay.
So HEP-HE is followed after the work developed in HE or PHE, which is called partially homomorphic encryption. So partially homomorphic encryption means you can only do the computation over encrypted data for a certain type of operator. For example, you can only do addition, or you can only do multiplications, but you cannot do crossover. That work is actually invented about 30 years ago, around the 1970s. And I think everyone familiar about RSA. They probably already use it daily in RSA right now. Remember, RSA is also a PHE. RSA is supporting for multiplication over encrypted data. So 30 or 40 years ago, this work is already started, but it take about 30 years for the researcher to cross the gap to be able to do addition and multiplication together. And as a computer scientist, we all know that enable addition and multiplication, basically we can do all the computation, right? So that is why HEP-HE, be able to work from 2009, because we closed the gap, and it's being developed very fast in the last few years.
Really, really interesting. Yeah, thank you for that explanation there, George. I feel like there's like 18 more things that I want to unpack that we probably definitely don't have time to unpack here. But the answer that you gave to me is very calming. At least, is this terrifying? The answer there is no. And there's a whole lot of research being done, right? You said, hey, this is not new, right? You're saying, hey, like people have known about this stuff. What you're saying, like 34 years ago, RSA, partial homomorphic encryption. This is something that's been in the works for a long time. And it sounds like only as of more recently have we been able to, okay, now we can really start unlocking the power of this research of this technology, which is what you guys at you all at Mind Network are aiming to do, which is awesome. So we only have a couple minutes left here. I do want to ask just one quick question and then let you guys have whatever final thoughts you want here. So for me, I'm a dev, right? I'm an engineer. A lot of the people watching this are engineers or security researchers. And for security researchers, a quick side note, this is going to drop a whole slew of privacy-focused bugs. So get ready to gear up on that for those of you who are looking to stay on top of your A game. So me as a dev and as a security researcher, what are the things that you want people to build? Do you want people to build on top of the Mind Lake right now? What can I as an engineer build? What can I start doing right now? Or what can I start doing soon?
I'll let George take that one.
Yeah, sure. So Mind Network is I would say infrastructure or a tools. For example, a data lake or database, and then bridges a protocol. So anyone who can using those tools to build fantastic applications, a particular use case, that will be super welcome and appreciated by us. So in terms of the use case, developer want to build on top of that. Maybe Christine can talk a bit more later. And in terms of the tools, we welcome the community to help us to develop SDK, developer monitoring, developer, attestation, those kind of tools together. And we are open sourced on GitHub. So really feel free for you to fork the code and then do a pull request to us, so we can share with more community, and the community can continues. And the license for our GitHub is MIT, so it's free for everyone to contribute.
Badass. Love to see that. So Christian, it sounded like George was kind of tossing it over to you. What are the business use cases that you want to see people build on top of this?
Yeah, I think he nailed it with just SDKs, one to access the data lake, or want to augment the bridge, or use the bridge rather. So the bridge market specifically, we think we've got a great use case there. It's kind of a consolidating market, and it really seems like it's poised for an overhaul. So we'd like to see a lot more activity there, and we think that the future is multi-chain. It'll be hundreds and hundreds of chains. And we'd like to see value being de-siloed. So that product in particular, we're really excited about.
Awesome, love that. So a couple people are asking for the link to your GitHub. I have dropped the link here. If you take a look at this, you can see, and let me even just show my screen real quick. Some of the SDKs. We have SDK for TypeScript, for Python, my data pack in Python. We have all these open source repos for you to fork, for you to play with, and build some really cool stuff that nobody has ever built yet, because this is brand new technology as of March, which is phenomenal to see. So go there, have fun, play around. And I guess before we jump off, because we're basically already out of time, is there anything else you want to tell people, let people know, have people do? Any last thoughts, comments, questions, CTAs, anything else here before we jump off?
From my end, from partnerships, just follow us on, you can reach out to me on Telegram. So mynetwork.xyz is the handle for everything. So Telegram, Discord, Twitter, LinkedIn, everything. And I'll be fielding a lot of that. If you have any questions, that's what I'd love to see. George?
Yeah, I'm cool. Yeah, so stay tuned and connecting to us if you need anything. Yeah.
Awesome. Well, thank you both so much for this call. I know I learned a ton, and you got me, unfortunately, really excited right before about to go to bed. So you've ruined my sleep. So thank you for that. But George and Christian, thank you so much for being here. Good luck to the developers who are looking to check this out, and good luck to security researchers who are looking to gear up on their privacy preserving security. So thank you all, and see you next time.
Thanks, Patrick. Bye, everyone.
Thank you. Bye.